Figure 8.5 Time2.java and Figure 8.6 Time2 test.java. We're now going to continue with our time class case study by enhancing the definition of class time with a new version called Time2. And there's a couple of new things that we're going to be introducing in this example, one of which is the concept of overloaded constructors. It's not uncommon for a class in Java to have many different constructors that allow the users of such a class to initialize objects of that class in many different ways. For our Time2 class, we're going to allow users to choose whether they want to get a default time of midnight, whether they'd like to specify the hour, possibly the hour and minute, the hour, minute, and second, or even another time object whose data should be used to initialize a new time object of class Time2 in the example. The other thing that we're going to be doing in this example is trying to build our Time2 class to make it more robust and to make it a properly software engineered class for the purpose of future debuggability, modifiability, and maintainability. And we'll talk about all those concepts as we walk through the source code for class Time2. Let's begin with the data in our Time2 class. We've got three private integers still called hour, minute, and second. And of course, in the prior version of class time, which was called Time1, we could only get default initialization of these because we provided no constructors. In this example, however, you can see here that we're providing 5 different constructors, each of which is called Time2 at line 12, 18, 24, 30, and 36. We know those are the constructors because remember that constructors have to have the exact same name as the class in which they are defined. So each of these is the constructor for class Time2. Only one of these is ever explicitly invoked when you say new to create a Time2 object. However, as you're going to see here, we have most of our constructors invoking one of the other constructors to do the work that the constructor needs to perform of initializing a Time2 object. So we're going to introduce a new syntax here as well for having one constructor invoke another constructor inside the class. Let's talk about the first line of each of our constructors to start out. At line 12, we have a constructor that says it receives no parameters. Now, when you define no constructors in your class, that indicates that the compiler should provide a default constructor that has no parameters for you. However, once you start defining your own constructors, the compiler won't do that for you anymore. So if you still want to provide users of your class with the ability to initialize an object using default initialization, then you have to define your own constructor with no parameters. So this particular constructor is designed to initialize a Time2 object to midnight, the default time. At line 18, we decided that some people might want to initialize a Time2 object by specifying just the hour. So we provided a version of the Time2 constructor that takes a single integer parameter and uses it to initialize just the hour, and then we'll use default values for the minute and second. Down here at line 24, we decided some folks might want to be able to supply both the hour and the minute, so we provided a Time2 constructor with 2 integer arguments for the hour and minute, and the second will get a default value of 0 in this case. And then we also decided that some people may want to initialize a Time2 object with all 3 values for the hour, the minute, and the second, as we had done basically with the setTime method in the Time1 class. Now, we also have one other constructor here, which you can see takes as its parameter a reference to a Time2 object, which we're calling time. In this case, what we're saying is that we'd like to initialize a new Time2 object using the data that already exists in a different Time2 object. So in that case, we're going to pull the hour, minute, and second values from another object and use them to initialize the new Time2 object that's being created. Now let's take a look at the bodies of each of our constructors as well. So the Time2 constructor with no parameters is the so-called default or parameterless or no argument constructor. You'll hear people refer to it different ways. And we have a special syntax in this constructor that uses this keyword to invoke another constructor of this class. So what we're saying here is we want to invoke this class's constructor that takes 3 integer values. And if you recall, the reason I know it's looking for 3 integer values is that I'm using whole number values here, and Java thinks whole number values are integers. So line 14 actually invokes the constructor here at line 30, which receives 3 integer values, and that in turn invokes our setTime method, which you saw in the prior time class example was able to validate the hour, minute, and second and make sure that we set the time correctly. Now, another thing that you have to keep in mind about the syntax you see here at line 14 is that this line of code must be the first line of code in the body of the constructor. If you wanted to do other initialization statements, they would have to appear after line 14 and before the closing curly brace of this constructor definition. All right, so again, this is a syntax for invoking another constructor, and you may recall that we had a good software engineering practice that we mentioned in an earlier example. If you already have a method in your class that does part or even all of what another method needs to do, simply call that method to do the work. So in this case, we have a constructor that already knows how to initialize an entire Time2 object by calling setTime, and rather than duplicating that code here, we're simply going to call that constructor and give it 3 values of 0 as the default hour, minute, and second values. Now, in the case of the constructor at line 18 that receives a single integer representing the hour, we also are going to call the 3-argument constructor of this class using the special this keyword syntax. And h will represent the hour, and we'll use default values of 0 for the minute and second. In the line 24 constructor, we receive 2 integers representing the hour and minute, and again we're going to use line 26 here to invoke the constructor at line 30 with 3 integer values, the hour value, the minute value, and 0 for the second. We already mentioned the fact that the 3-argument constructor calls setTime to do the work of setting the time. And then finally, at line 36, we have the Time2 constructor that receives another Time2 object as its argument. And take a look at the constructor here. The body is once again invoking the 3-argument constructor back at line 30, and the 3 arguments are time.getHour. You're going to see the getHour method in a moment. It returns just the hour for whatever Time2 object you specify. Time.getMinute, and again you'll see this momentarily, where getMinute returns the minute value for whatever time object you specify, and similarly time.getSecond returns the second object for whatever time object you specify, Time2 object. So we're going to take these 3 object values from the time object that we receive as a parameter and hand that to this class's constructor up at line 30 that takes 3 arguments. It in turn will pass those to the setTime method to do the work of initializing a Time2 object. And in fact, setTime's body has been redefined from our prior example. If you take a look at setTime, it still receives 3 integers that represent the hour, minute, and second, but we decided to make this version of our class more robust by defining setHour, setMinute, and setSecond methods so that a user of class Time2 can independently set those values. So you might consider an alarm clock, for example. Some alarm clocks allow you to set the hour and minute separately, and if we were going to use an object of class Time2 to back up an alarm clock as the actual data underneath the hood, it might be handy to have a setHour and setMinute method. So our setHour method will take the hour value you pass in, and it will validate the hour to make sure that it's in the proper range. Our setMinute method will do the same thing for the minute value m, and our setSecond method will do the same thing for the second value s. And you can see our 3 new set methods here at lines 53, 59, and 65. setHour receives an integer that represents the hour, and you should recognize this expression from our first Time1 example, where we're checking to make sure that the hour value is greater than or equal to 0 and less than 24. If so, we use that value to initialize the hour instance variable, otherwise we use 0. And similarly, set minute now does the same work for a minute, checking to make sure that the minute is in the range of greater than or equal to 0 and less than 60. And similarly, set second receives the second value and makes sure that it is in the range greater than or equal to 0 and less than 60. Now, in the prior time class example, we did not give you a way to obtain the hour, minute, and second values directly. What we could do was obtain a string that contained the formatted information. But let's say, for example, you want clients of your class, the code that uses your class, to be able to calculate the difference between two times. We need numeric values for that purpose. So we've provided a getHour method that takes no parameters and returns an integer representing the hour inside of our time object. We've provided a getMinute method that takes no parameters and returns the integer representing the minute, and a getSecond method that returns the second. And finally, we have our toUniversalString and toString methods as well. Now, you'll notice inside the toUniversalString method that we're still using the string.format static method to create a formatted string in which each of the three values is output as a two-digit number with leading zeros as necessary, and they are all separated by colons. But here's a key difference from our prior example. We're using getHour, getMinute, and getSecond to retrieve the hour, minute, and second for this object. In fact, getHour here is really this dot getHour, getMinute here is really this dot getMinute, and getSecond here is really this dot getSecond. And even going back up above, in our setTime method, these are each this dot setHour, this dot setMinute, and this dot setSecond. The compiler implicitly adds the this dot, and we're just taking advantage of that in our code, but you could certainly explicitly put this dot if you would like. So going back down to our toUniversalString method, we're going to format the hour, minute, and second and return that string. And similarly, in the toString method, we're still formatting it the exact same way, but rather than explicitly accessing the data in our class, we're using the get methods to obtain the value of the hour again here, the value of the second, and the value of the minute, depending on what it is we need to output. And by doing this, we're actually protecting ourselves against future change in this class and making our code easier to debug and modify as well. So let's talk about some of the software engineering issues in this class definition. By minimizing the total number of points at which you directly access the three instance variables, hour, minute, and second, you also minimize the total number of points in your code where you may need to debug your code. For example, let's assume that the hour value is not being set correctly. Well, if you scan through this class definition, you'll see that the only piece of code that ever directly modifies the hour is this one method, setHour. So if the hour is not being set correctly, I can focus my debugging on this particular method definition to see what's going wrong. And similarly, only the setMinute method modifies the minute, and only the setSecond method modifies the second. So if either of those are not being set correctly, we can focus our debugging attention on these methods. Another benefit of using your set and get methods throughout your class definition is if you wanted to change the internal data representation. If you look at what we have for our data representation right now, we're using 3 integers which are each 4 bytes of memory. But we could easily represent the time of day as the total number of seconds in the day rather than as 3 separate integers, hour, minute, and second. So if we wanted to make such a change to our class where we reduce the amount of memory the class requires from 3 integer variables to 1, we can do that. And if we use our get and set methods correctly throughout the class definition, we will minimize the total number of places where we need to change our code. So for example, if you take a look at our constructors, at no point in the body of any of these constructors do we ever mention one of the instance variables directly. So as long as the way that we invoke these different constructors remains the same, or as long as the fact that we have a getHour, a getMinute, and a getSecond remains the same, we do not need to modify these constructors if we make the change from 3 integers representing the time to 1 integer representing the total number of seconds in that day that have gone by so far. If I scroll down here, even my set time method doesn't need to be modified, because even in here we do not directly access the hour, the minute, and the second variables. Our set methods for the hour, minute, and second would need to be modified because they are indeed accessing the instance variables directly. So in these methods we would have to build up the total number of seconds value by breaking it down first into pieces that represent the hour, minute, and second, changing the particular component that we wish to set, and then calculating the proper number of seconds to store once again. And similarly, in our get methods, which are currently returning the hour, minute, and second variables, we would have to do some calculations to figure out what the hour is based on the current total seconds in the day, what the minute is based on that value, and what the second is based on that value. So the 3 set hour, set minute, set second methods, and the 3 get hour, get minute, and get second methods all would need to change based on the data representation change that I'm discussing. Separately, 2 universal string and 2 string would not need to change because they also do not directly access the data throughout their method bodies. So it's a good software engineering practice, even in your own class definition where you have direct access to your data, to make sure that you use your get and set methods internally, not only to help you minimize the total points within your class where you're modifying your data, but also to help you protect against future modifiability, and also to help you with your debugging as well, because the fewer touch points you have, the easier it is to localize where the problems are coming from.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.